Section 5.3, Translating Parabolas. Now, if you remember when early in the year we were graphing absolute value equations, we had this equation right here, y equals the absolute a times the absolute value of x minus h plus k, and remember at our vertex that we said was h comma k. And the parent graph, which is the smallest graph of this function, which goes through the origin, was at y equals the absolute value of x. So in the last section, 5.2, we talked about parabolas or quadratic equations, and the parabola is the shape that they make. So y equals ax squared plus bx plus c was the standard form for a quadratic equation. Now we also have another form. So instead of just the standard form, we can have vertex form for a quadratic equation. And of course, just like lines, you have, remember, slope-intercept form, point-slope form, and standard form for equation of a line. It's kind of the same idea. So what do you think vertex form is nice for? Of course, in the equation, it's easy to see what your vertex is. The parent function for this would be y equals a x squared, so that would be the smallest shape, and generally the parent function is y equals x squared or y equals negative x squared, depending if it's opening downwards. So remember, just like our absolute value functions, that h, what did it do to your graph? So remember, it's attached to our x. How does x move? Left and right on our graph. So h moves our graph horizontally. And so in this case, if h is greater than 0, that means in your equation you would have y equals a times x minus h squared plus k. So if you have x minus h in your equation, it means you're going to move your graph to the right. And if h is less than 0, so like let's say that our h value was h equals -3, then in this case you would have y equals a times x plus h squared plus k. And the reason that would happen is because you would get y equals a times x minus -3 squared plus k, if I'm using -3 as an example. And notice that that minus minus becomes a plus. So that's why in this case, if it does that, then we are going to shift our graph to the left. And just like with absolute value, remember that h was opposite thinking. Same thing with quadratic equations. So the k then moves our graph up or down because we consider it attached to our y value. And so up and down changes your y value, so it's a vertical. So it moves the graph vertically is what I should write. So if k is greater than 0, it's going to shift your graph up k units. If it's less than 0, then it's going to go down k units. And the vertex for our graph here is going to be h comma k. And notice that this is for this graph right here when x minus h is always our vertex form. So if it's minus h, h is opposite of minus h, so remember you have to do the opposite of that. So if this was my parent graph right here, y equals x squared, then let's say the transformation would move it over h and up k, and that's where we get this transformed graph right here. Now the axis of symmetry, remember, is always the x coordinate of your vertex, so x is equal to h for the axis of symmetry in this case. So let's go ahead and graph some of these in vertex form. So for the first one, the first thing I look at, remember, is my a value. So notice that your a value is still the same. It's still what's in front. So this right here is your a value. So I'm going to write that down. So we have a equals -1/2. So since our a value is negative, remember that tells me my graph is going to open down. And since my graph's opening down, that means that we have a maximum for our vertex. So then the next thing I'm going to find is my vertex. And this one's easier than standard form because it's given to you in your equation. So this right here would be my h, and this right here is my k. So h, remember you do the opposite, is 2, and k stays the same, is 3. So that means that my vertex, remember, is h comma k. So in this case, it would be 2 comma 3. So that was real nice. We didn't have to do the negative b over 2a. That's only for standard form. So I'm going to plot that on my graph, right 1, 2, up 1, 2, 3, which would be right here on my graph. Then the next thing I'm going to do is I'm going to find the y-intercept, because that's always a nice place on your graph. So the y-intercept, remember, in order to find it, you plug 0 in for x and solve for y. So the y-intercept, plug 0 into x and solve for your y. So when I do that for this equation, so let's do that off to the side, I would get y equals negative 1/2 times 0 minus 2 squared plus 3. So then 0 minus 2 is negative 2, so I get negative 1/2 and then negative 2 squared plus 3. Negative 2 squared is 4, so now I have negative 1/2 times positive 4, because that negative is being squared, plus 3. 4 times negative 1/2 gives me negative 2 plus 3, so then we get a y value of 1. So my y-intercept is at 0, 1. So then I can plot that 0, 1. And it makes sense that it's lower than my vertex, remember, because our parabola is going to be opening downwards. So remember, the parabola is the shape of your graph. So the next thing I can tell is from my axis of symmetry. So I know my axis of symmetry is the x-coordinate of my vertex, so x is equal to 2 in this case, and so remember, it's a line of symmetry which cuts your graph in half. So this would be the line that cuts my graph in half at x equals, in this case, 2. And then I can also tell that I know this is a, in this case, minimum or maximum value, sorry, because your graph's opening up, so it's a maximum value is, and remember, the maximum is always the y-coordinate of your vertex, so the highest possible y value that we can have on our graph in this case would be 3, and that would be at our vertex. Now remember that we can go ahead and graph this by making an xy chart, so I'm going to do that off to the side right here. We already have our vertex, which we know is at 2, 3. So remember, you pick points to the left or the right to come up with them. Well, I already have the point for my y-intercept, which is at 0, 1. And so I'm just going to do points to the left. So now I'm going to plug in 1 into my equation and see what I get. So remember, you always plug it into your original equation. So I have negative 1/2 times 1 minus 2 squared plus 3. So when I figure all this out, I plug it in, I get y equals negative 1/2, and then 1 minus 2 would give me negative 1. Negative 1 squared is positive 1 plus 3. And so then notice here I would get negative 1/2 plus 3. And then in this case, I'm going to end up with a fraction. So if that happens, you can write that down, but sometimes I might just go to the next one. But what's easier to do to find your points is I would just plug it into my calculator. So on my calculator, I get go to your y equals, you have negative 1/2. Remember to put fractions in parentheses on your calculator, and then parentheses x minus 2. Don't forget to square it, so use your caret key. Or actually, we can just do the square there if you want, so you can just also hit the square button, doesn't matter. Same thing. Now, if I go to my graph, hit zoom 6 to go to nice graph window. And here's my graph. If for some reason it didn't work, make sure your second y equals your stat plot is off right here, because if it's on, you won't be able to graph that. So now I have my graph. It's opening downwards, so we know we're correct. If I hit trace, I have 0, 1, which is my y-intercept, which is nice. If I go to second trace value, I'm going to check my vertex. So if I enter an x value of 2, that's my y value is 3. So I notice that that is the highest on my graph, so that's kind of cool. And then if I go to my table, I look at the value when I plug in 1, again, notice you get that fraction, so 2.5. So I'm going to go to the next nice value. So I have 0, 1, and then this is my vertex here, 2, 3. So 1, 2.5. So let's do instead 4, 1. So we'll use that for a value. Notice on the other side then, we should have 0, 1, and 4, 1 correspond to each other. And let's do 6, negative 5. So we'll use 6, negative 5. So on my table, I'm going to use, instead of that decimal, I'm going to use 6 and -5. So I have right 1, 2, 3, 4, 5, 6, down 1, 2, 3, 4, 5. And again, you have your calculator to use, so you might as well use it as a nice tool. So I have corresponding points now. I can use my table to plot the other points, that's fine, or I'm just going to use my corresponding points. So we have 0, 1, which means that I have 1, 2 away, 1, 2 away, so I know that that point's going to be right there. The 6, -5 is 1, 2, 3, 4 away from my axis of symmetry, so 1, 2, 3, 4, and the other side would be right here. And now I can just go ahead and graph. Like I said, you don't have to do the corresponding points. You can just use your calculator, that's fine too. And this looks like what it looks like in my calculator, so I know I did everything correctly. So let's go to this next graph that we have right here. So for this next graph, I'm going to do the same thing. So I know that the first thing I'm going to look at is my A value, which in this case is 2. If there wasn't a number there, then it would just be 1. So I know my graph in this case, instead of opening down, it opens upwards. So then the next thing I'm going to find is my vertex. So remember h and k. So h in this case, since it's x plus 1, h would be -1, k is equal to -4. So that means that the vertex is at -1, -4. And then I know that I want to find my axis symmetry, my maximum, the y-intercept. So let's go ahead and do the y-intercept. So y-intercept, when I plug 0 into my equation, I get y equals 2 times 0 plus 1 squared minus 4. So then this gives me 1 squared is going to be 1, so 1 times 2 is 2, and 2 minus 4 is -2. So I have a y-intercept of 0, -2. So let's plot the vertex and the y-intercept. So -1, 1, 2, 3, 4 is my vertex, and then I have 0 down 2. So then I also know that my axis of symmetry is your x-coordinate vertex, so x equals -1. And then I know that my graph is opening upwards. So since it's opening up, I have a maximum value of the function is the y-coordinate of your vertex, which is negative, or sorry, I just said maximum, so this should be minimum. I don't know what I'm doing right here. Minimum. The minimum value is, in this case, -4, so that's going to be the lowest point of my graph. Now my axis of symmetry cuts my graph in half right here. And then I have my corresponding point from my y-intercept, which is on this side, so that's the corresponding point there. So then I can just go ahead, go to my calculator, and plug it into my y equals to get my nice table values. So I have 2 parentheses x plus 1 squared and then -4. Oops. So if I go to zoom 6 or just hit graph, because we already did zoom 6, I can check my values. So second trace value, if I do 0 for x, notice I get my y-intercept's -2, which is helpful. And if I do second trace again, I'm going to do my vertex and check. So -1, -4, notice it's the lowest point in our graph. So those 2 points check, which is good. So now let's go to our table, and I always go to where my vertex is. So my vertex is at 0, -2, so I'm going to help this use this to help me graph. So I have 2, 14, and I have -2, -2. So let's use some of these values. So we'll use 1, 4, and -3, 4. So those are going to be the other values that I use. So we had 1, 4. So over 1, up 1, 2, 3, 4, and then that means I also have -3, 4. And again, I just use my calculator to find those. Now I can do my parabola shape, and it should look like what your graphing calculator looks like. So looks like I did everything okay. So those are the graphs. So now let's do the next point. It says, write the equation of a parabola in vertex form, given the vertex and a point. Now we're going backwards. So for this, you have to remember what your equation is. And your equation, I'm just going to write down here, is y equals a times x minus h squared plus k. So remember, your vertex is your h and your k. So that means that my h value is 3 and my k value is 4. So that's what I'm going to plug in for h and k. Then I have my point. So that point is just going to be in any x and y that's on my parabola. So I'm going to say x is equal to 5 and y is equal to negative 4. So notice that I have a y value, I have an x value, my h, and my k. The only thing I'm missing is a. So that's what I'm going to find when I plug these values into my equation. So that's what I'm going to do. So my point, I have a y value of negative 4 is equal to, I don't know a, so I'm going to solve for that. And then I get x, which is 5, and then minus my vertex. So my h value is 3, so minus 3, and that's squared. And then I have my k value, which is 4, so then it's positive, so plus 4. So now all I have to do is solve this equation that I have right here. So when I do that, I get negative 4 is equal to a. 5 minus 3 is just 2, and 2 squared is 4. So really we have 4 here times that a plus 4. So then if I rewrite that, negative 4 is equal to 4a plus 4. Solve the equation, subtract 4 to the other side. I get negative 8 is equal to 4a divided by 4. And a is equal to negative 2. So now that I have my a value, I have my vertex, I can actually write the equation. So the equation for this would be y equals negative 2 times x minus my h, which is 3, squared, don't forget that squared right there, plus k. And my k value is 4. So this would be my vertex form for my equation. Now, for this, if I wanted to put this in standard form, how would I go about and putting this in standard form? Well, standard form, so I'm just going to make a note, to put in standard form, which is ax squared plus bx plus c, you have to FOIL this out, or box. So you would FOIL and combine like terms. So that's something that we will also practice. So for you guys, why don't you practice this one right here, number 2, and see if you can do that on your own, and then we'll also talk about it in class. So now let's look at the last part that we're going to do. We're going to convert from vertex form, so from standard form into vertex form. Now, in order to do that, let's look at this first equation that I have. Here's the steps above it that you can read. Now, this equation is in standard form. So if we want vertex form, remember vertex form is y equals a times x minus h squared plus k. Notice that in order to have vertex form, what 2 things do I need? I need my a value, and the second thing that I need is the vertex. Now, in standard form, we have ax squared plus bx plus c. So notice you have your a value here. So that's kind of nice. That means we need to find the vertex. And remember, we learned in standard form, how do you find the vertex? Negative b over 2a, and then plug that equation back into your equation to find the y value. So in this case, I know that a stays the same. So a is equal to negative 3. I'm going to write down the other ones as well. B is equal to 12. C is equal to 5. So that's going to help me find my other part. So this is my a value. I have that. So the vertex, remember we have x equals negative b over 2 times a. So that's going to be equal to negative 12 over 2 times negative 3. Which is negative 12 divided by negative 6, which ends up giving me 12 divided by 6 becomes positive, in this case 2. So now that I have the x coordinate of my vertex, I plug that into my equation that was given, and solve for y. So we have negative 3 times 2 squared plus 12 times 2 plus 5. So now if you plug this into your calculator or go ahead and do this out by hand, you get a y value of 17. So now I have the vertex, which is 2 comma 17. So I have my h and I have my k and I have my a value. All I have to do is plug it into my equation, which is right here. So we get y equals -3 and then x minus 2 and then plus 17. So this right here, and I forgot the square, so don't forget that, would be my equation now written in vertex form. So again, we went from standard form to vertex form. So why don't you guys see if you can do number 2 on your own? And number 2 is going to end up with fractions for your vertex. So if you get that, don't worry about it. It's okay. And let's go to one last example. Now we also have to go from a graph to writing the equation. So that's the last part. So when you're going from a graph to equation, and it says to write it in vertex form, well, what do you need? So remember, you have y equals a times x minus h squared plus k. I need my a value, and I need my h and my k. Well, what do I have on this graph? I have my vertex, which is something we want. My vertex is at -1, 0. So remember, that's your h and your k. And I also have a point. And the point that's given is -2, 2. Did I have to use -2, 2? No. There's other points on the graph that you could use. So if you look at your graph, it's kind of hard to see here, but I also have this point right here. So I could have used the point instead 0, 2, and I would end up with the same answer in the end. So remember, this is what we just did in that last problem. I'm going to use this for my x and my y. I have my h and my k, which means I need to solve for my a value. And when I do that, I get -2 is equal to a times x, which we're using -2, minus h, so minus -1 squared, and then plus 0. So minus minus becomes plus right here. So we have -2 equals -2 plus 1 would give me -1 squared, which is 1. So a plus 0, which we don't need to write. So a is equal to -2. Now that I have that, I know h is -1 and k is 0, so I can write my equation. Y equals -2 and then x minus h, so x minus minus becomes plus 1 squared and then plus 0. So this would be the vertex form for my equation. Now, of course, you don't really need to write that 0 there. It's just a placeholder for right now. So if more correctly, or what would be correct, would be to write this like this. So this is the equation in vertex form. So normally we don't write that 0. So why don't you also see if you can go ahead and do B, and then we'll talk about this in class.